Hey there, in this video we are going to complete our carrying capacity foldable. So this is packet page 158, and what I did is cut out the actual foldable part right here. I did keep the directions in my notebook just so that I would have them. So these are glued up at the top, and then I glued this closer kind of to the bottom, middle, and then you need to fold along these dotted lines right here. And then you will cut these solid lines in order to make 3 flaps. And then we'll write our answers to each of these questions underneath those flaps. So let's go ahead and get started. So the first thing we need to do right up top in the directions, it tells us to answer the 3 questions, but it also says the very last line, draw a line on the graph to identify the carrying capacity of this population. So we need to draw a line. So I've done that here. It's kind of start at the E here in size, right? And just go straight across with a dotted line. So this is the place where the population size kind of stabilizes. And so that is our carrying capacity. We can see that there's some fluctuation above and below the carrying capacity, but we do not see where this population is continuously exceeding carrying capacity, right? They are not experiencing exponential growth, but there are, there's maybe one generation where they're above, and then it looks like maybe 2 or 3 generations where they're coming down below carrying capacity. Right. And then they reach kind of a stable point where there's enough resources and they come back again and they're like, oh no, we exceeded it. And then they dip down again. But this is our carrying capacity, which again, we defined as the maximum number of individuals that a single environment can support. So let's take a look at our first flap. So this is just, again, a note reminding us that this is logistic growth or an S-curve. Okay, question number 1. What are the 4 most significant factors that determine carrying capacity? So underneath that flap, I put a list, number 1, 2, 3, 4. So number 1 is food. Is there enough food for organisms to have enough energy to survive and reproduce? Same thing with number 2, water, right? Water is essential. You can't go more than a couple days without water. Number 3 is space. Is there enough room in the environment for there to be low competition? Remember, we talked about how competition can have a negative impact with the individuals or with the species involved. So space can definitely determine carrying capacity. Excuse me. And finally, number 4, environmental conditions. So if you have extreme temperatures, cold or hot, that can influence your carrying capacity because that could influence what types of organisms could live in that habitat. And then the same thing for precipitation. But these are mostly your abiotic factors that can limit or determine your carrying capacity. So food, water, space, and abiotic factors or environmental conditions such as temperature and amount of rain, right? Precipitation, amount of rain. Question number 2, what can cause carrying capacity to change? So any change in a limiting factor could certainly cause the carrying capacity to change. So if you are an organism living in a deciduous forest, which is the environment here in North Carolina, it's a pretty stable, temperate environment, and there is suddenly a lack of water. Maybe we're experiencing a drought. That could limit carrying capacity. It would definitely lower carrying capacity. But we could also cause carrying capacity to change by there being an excessive amount of water or food. Other things that could cause carrying capacity to change are natural disasters, disease, and human activity. We'll talk later on about deforestation, habitat destruction, things caused by human activities. And finally, number 3, what happens if a population exceeds its carrying capacity for a long time? So if you are constantly exceeding your carrying capacity, you could completely deplete or exhaust the resources in that environment. If you completely deplete your resources, that could cause, if not the entire population, then a large majority to die off, which could lead to, if not extinction, then definitely you being endangered. A good example of this, though, is in the Yellowstone National Park, where the caribou or the moose population, they didn't have any predators. There were no wolves for a number of years, and so they overgrazed their habitat. And it got to the point where their numbers were just extreme, that they were running out of food because they had no predators to control their population numbers. And so finally we reintroduced wolves into Yellowstone National Park, and within a few years the wolves had the population of the moose under control, and so they stopped overgrazing because there just weren't as many moose to feed. And so the plant life was able to come back, and they were no longer starving to death. So that's a really good example of how, again, that predator-prey relationship can actually cause stability in an environment between the organism and its abiotic environment. So that is it for this carrying capacity activity, this foldable. If you have any questions or concerns about any of the answers that we went over here for this foldable, please let me know. Thanks.